screen? Okay, so I guess you guys see my screen now?
Oh yeah, you're good. Looks perfect.
Perfect. So let me just go ahead and maximize this one. So what I plan to do is I'll do a few slides, but I do want to show you like the actual work and how it happens. So we'll do a couple of demonstration that way as well. So hopefully it'll be a little bit more interactive and useful. Great. So, so what Aqua wants to do is we want to be able to protect your pipeline, your infrastructure, and your workload. We want to be able to, basically adopt security from the for modern cloud native application, and we don't want to be a barrier to your developers. So it should be integrated with the developer so that there's no hindrance, there's no friction. But we know whenever you have friction, developers are going to find a way out of it. I used to be a developer many years ago, and anyone puts a roadblock in front of me, I would figure out a way to get around it just because it was easier to do that. So ideally, what you want to do is, we want to protect the pipeline. This is just a basic overall. It goes from your pipeline, then it goes to your infrastructure, then it goes to your workload. This is how a typical flow it happens here. So the first step we want to be able to do is we want to be able to scan the pipeline, scan the build in the pipeline. We want to be able to, get all the risks, prioritize the risks from critical all the way down to low. We want to be able to give you guys some advice of how to go about fixing it. If there's a fixed version available for it, we'll tell you what the fixed version is, and then you can go ahead and fix it and redeploy it. That's really step one of it. And then it goes on to your infrastructure side of the house. Um, it goes down to infrastructure. We want to continue to have visibility once it's deployed. So, you just don't stop when you scan the image, right? You want to be able to protect it all the way to the runtime when it's running. So how do you do that? So this is what we're working at. We want to be able to have the visibility. We want to be able to detect any new risk that might occur or anything wrong going on that side. So really, that's when you look at the security posture for the image, there's a couple of things we want to do. We want to be able to check for any vulnerabilities in the open source components that you have. We want to be able to check for malware. We look at the signature of the malware to see if it matches anything in our malware vulnerability listings. We want to be able to check for sensitive data. This is really important. The sensitive data is like the hard-coded keys or private certificates or secrets that might be left on the image. Many developers, need access to resources when they're developing, so they have the access to those keys. But sometimes they forget to pull those keys off. And if you leave the keys in your image and you deploy it and you make it publicly available, hackers can get access to those, and they really have the keys to the kingdom at that point. So we want to be able to make sure that before it goes any further, we want to check to see if there's any sensitive data, any keys that's left there. If it is found, you want to fail the build and take care of that right away. You want to check the properties of the image, make sure that the user is not configured to be running as a root user, for example. You could also check for any particular packages, any open source licenses you might not be able to use or you should be using, and then ability to write your own checks there. And the last one is the dynamic analysis. This is relatively new to Aqua. We released it last year, I believe in June, and this is really a game changer. Everything above the dynamic analysis is really a static scan. We're going to check for all that. It's really based on the image at that moment in time. What dynamic analysis does, it takes that image, we put it into a sandbox environment, and we watch the behavior of the image as it spins up. So like supply chain poisoning or compromised behavior, like pulling down bad malware, ransomware, or anything bad after the image has been scanned. But when an image spins up, we want to be able to catch that as well. And ideally, you want to be able to you want to do it early on. So you want to integrate it with your CI/CD tool. If you're using Jenkins, Azure DevOps, or Code Pipeline, or any of the GitLab, whatever it might be, you want to be able to integrate it early on and capture it before it makes it out to the next step. As we all know, the sooner you catch it, the cheaper it is to fix it, financially and resource intensive wise. If it gets out to public and then you figure it out, then it's usually too late. Hackers would know by then and could have taken advantage and caused a lot of issues. So, you want to be able to sort it out and look at the risk of your environment. So you might have vulnerabilities in your images, but your image is not being deployed. It's not being used. So if it's not running, no one can actually hack it. No one can take advantage of it. It's just a bad image. But then there are some images that have exploits available for it, and then you actually have it running. So you want to be able to detect that and say, you know what, this has a vulnerability and it has an exploit associated with it. If there's an exploit associated with it, you can be sure that the hackers or bad actors have that already programmed in their scripts, and they're already combing the internet for that particular vulnerability and let their bots, take advantage of it. So, one of the things we do at Aqua is we actually integrate with the exploit DB, so you can see you can see the actual code that is used to exploit that vulnerability. And in some cases, there's a mitigation code as well, like it tells you this is what you should do to prevent that from happening. The next thing is this is a screenshot of, the one on the left is a screenshot of an actual vulnerability that we found. This is on Nginx, and this is what the results will give you. The one on the right is the actual output from dynamic threat analysis, DTA for short. So this is, you can see all the network activities that are happening, and we've mapped them, the endpoint where it's going to. We see the result, and at the end of that kill phase, we see that, hey, there's a crypto miner being deployed here. So, we give you all that information really nicely. Another thing that we do, another thing that we find our customers really like is how we prioritize the risk. In this case, an example, actually, I don't know how many there are, but in my personal demo environment that I'll show you, we actually have like 4,000 vulnerabilities, which is relatively small when you think about it on enterprise scales. Enterprise could have thousands or tens of thousands or even millions of vulnerabilities on the environment. So what most people are used to is, they were categorized from critical, all the way down to low. But what we did in Aqua is we did risk-based insights. So we were going to base this upon the risk of their vulnerability. So default, we have it from medium to critical. Then as you go towards the right, you can see that the number is slightly decreasing in the network attack vectors. Out of those 4,000 or so vulnerabilities, how many of them have available exploit? This is when they have a reference in the exploit DB. Out of those, how many of those are actually remote exploitable? That's 29. And then all the way on your right-hand side, you can see that there's 24 exploitable workloads. As a security professional, if you're faced with 4,000 vulnerabilities, you're just gonna be like, how do I handle it? I don't have the resources or the time to take care of all those issues. But when you look at this risk-based insight, this 24 is telling you that you have 24 vulnerabilities that are actually running on your environment at this moment in time. So, this is what I need to take care of. I need to take care of these 24. All the others are in the image, but they're not actually running. So if they're not running, they're not going to be affected. But those 24 are running and they are going to be affected. So you really need to take care of those 24 exploits. Another thing we have in Aqua is our Kubernetes security posture management. If you have a Kubernetes environment, you will able to do a number of tests. One of the things we do is our Kube Hunter test. So Kube Hunter is our open source Kubernetes penetration testing tool. So if you go to kube-hunter.aquasec.com, you can actually go and you can read all the passive and active tests we do. We also have a link to our GitHub page, so you can see the actual source code, because it is open source. As was mentioned earlier, there's other open source tools out there, like Starburst, Trivy, a few other projects we have there. Eventually, when those projects becomes mature enough, we actually import it into the Aqua the enterprise level of the solution. So Kube Hunter is one of those solutions that we actually built into the solution. Another thing we have is our Kubernetes assurance policy. So we're based, we could scan the image based upon what the Kubernetes assurance policy says, like if it has root access, if seccomp profile is enabled or disabled, if CPU is limited or not. So we have all those controls as well. And then we also do our Kubernetes benchmarks, so the CIS benchmarks. So those run automatically every day against your environment, and you could check your environment against the benchmark to see how it it checks against that. The next thing that we do is really give you a good view of your exposure, of your risk, of your environment. So we have something called risk-based insights that really gives you the risk, that gives you a quick 10,000-foot view of the risk of your environment. So really quickly from that view, I get to see, criticals and highs, so the red and dark red vulnerabilities and risk of my environment. Oops, sorry. In this particular, sorry. In this particular case, you can see the sock shop namespace has a number of criticals and high vulnerabilities. So it's really telling me that, hey, I need to look at this one. This is the biggest namespace with most workloads on it. It has a lot of issues there. So it's not a clean environment. I really need to take a look at that. I could quickly click on one of those containers and get the information on it. So it's telling me that it has 54 total vulnerabilities. Due to my Kubernetes assurance policy, the memory request was not requested, was specified. Root is not read-only. It runs with a UID of less than 1,000. Could evaluate its privileges. So you have all these issues that we were able to detect, and then you can just dive deeper into one of these containers and see what they are. So that's step one. We want to be able to scan that image. We want to make sure the image is fine from the scan. We want to be able to do a dynamic threat analysis to make sure the image is not doing anything suspicious or bad after the fact has been scanned. So you want to make sure all that is taken care of. Then it comes to really step two. So after the build is done, we're going to, after the scan is done at the build pipeline, we're going to push it to the registry. From the registry, we're going to push it to your infrastructure. And before that happens, we're going to be able to see, we're going to check to see if the image is allowed to run. So the acceptance gates. The way we do it is we do a number of things. The first thing we'll do is we're going to check to see if the image is known to Aqua. Has it been scanned by Aqua? Is it in Aqua's database? If it is, then it's going to go ahead and it's okay, you're good. I know you, you're fine. The next thing it's going to do is it's going to check to see it's been scanned by Aqua, but did it pass the security scan that we did before? If the answer is no, if it's not compliant, it won't let that image go forward. And is this image expected, meaning it has scaled up and is known to, it is what we expected. If any of those are no, Aqua is going to prevent that image from becoming a container. Why this is really important is when you think about what happened to many public companies out there. I won't mention their names. It's an auto manufacturer, electric auto manufacturer. No names mentioned here. But hackers got in, they deployed crypto miner on their environment. So if you had this enabled, this acceptance gates would have prevented those crypto miner containers from ever spinning up to getting on the environment. It would say that, nope, I don't know what you are. I'm not going to let you run. End of story. So it's a really good way to prevent any rogue containers from getting on your environment. We're just not going to let it happen. Then the next one is really the workload acceptance, right? So we want to make sure this is just an example of it actually happening. I tried to run run an image that I never scanned, or I scanned and it failed the Aqua scan. It failed the check. So this is the error you would get. Aqua Security image is marked as non-compliant. So it was scanned, but it failed the security check that we put in place. So therefore, we won't let it run. So now that it's gone through the step three and it got to the acceptance part, we're going to actually go into the actual protection of the container now that's spun up as a container. We always want to have visibility in it. We always want to be able to detect the threat, uh, detect any behavior drifting, and give you a response to that. So the way Aqua does it is really through our runtime policy. You know, we have a number of controls available over here. There's actually a little bit more than this. So we want to be able to check to see, if the image is compliant. We want to prevent drift prevention. Drift is what drift really is something that has been added to the image or the running container after it's been scanned or after the image is running as a container. So after it is spun up, something was added to it. The whole idea between containers is that it should do what it's supposed to do. So if you wanted to do something, you would build it into the image, and you would push that image onto production, and should only do what you specified it to do. So you want to maintain the immutability of the image. So you don't want anything to be added after the fact. If you need something to be added after the fact, you take it back to the developers and you have them build it, and they have them push a new build in. You never should be able to exec into the container, or you never should be able to pull down anything if you did exec into the container. And our Aqua's runtime protection will help prevent that from happening. Here's an example of allowed or not allowed executables. These are the only executables that are allowed. If there's anything outside of these executable, we're going to get a permission denied. So even, I'll share a live example of this exact thing, and then I could just move around and change it around however you want me to do something. But here, for example, I ran curl, and I get permission denied here. I get permission denied here because curl was not in the on this profile that we created. Now, this is really important because again, images should only do what they're supposed to do and nothing else. So a good way to control that is through our image profiling. What that does is we're going to watch the behavior of your image as it spins up, as it's being used in a safe environment, like doing UAT, for example, over a set period of time. And say, during this time period, these were the commands that were executed. And this is the only command that I'm going to allow it to run. Every single other command that you have on that base image will not be allowed to run. The alternative really is to take that base image and strip everything off of that base image that you don't need. That's a lot of work, and it's really hard to maintain. An easier way to do it is just to have Aqua profile it, and I don't care what else you have on that image. It doesn't matter to me. This is the only thing I'm going to allow it to run, and that's it. End of story. Another example, I really like this control, this drift prevention. This is really, really easy to implement and really powerful. All I have to do is in one of my controls, I just have to make sure that this checkbox is checked. If it's checked, I'm good to go. What this one checkbox is going to do is it's going to prevent any executable that was not on the original image from running. So if you think about, there's no learning here. There's no, waiting, 10 hours, 24 hours, 40 hours, whatever it is. There's no waiting period. This takes effect immediately. So if you start up in a container and you exec into it and you try to download something that wasn't there, it just won't let it run. You'll get this permission denied. In this example here, what we're doing is we're exploiting WordPress because we know how secure WordPress really is. We're going to exploit it. We're going to download a crypto miner, and we're going to try to run the crypto miner, and we're going to get permission denied. End of story. That crypto miner, that executable was not there when the image started up, so I'm not going to let it run. You might say, well, you know what? I could build that crypto miner inside the image and then launch it, and then it should run. Well, the problem with that is, if you scan the image with Aqua initially, we would have found the crypto miner. We wouldn't have let that run. Or if you try to implement that crypto miner after you scan it, and then try to initiate that image as a container, it won't run either because that introduced a drift. So Aqua would say like, nope, a drift has occurred on your image. It's not the same image that I scanned in before. So you need to take it back and rescan that image and rebuild that image and go through the process. Another good thing is, we're able to capture forensic data. What this is, we're going to capture all the commands on that have been executed on that container. We can also do it for the host side of it at the side as well. But we're going to capture all the commands that are running on that you ran on the container. We're going to see any network activity, and we'll get you all that information. So you get detailed information. Like here, for example, you can see that the root tried to use this command here. So you can see like what happened and where it happened, and then it will tell you that Aqua blocked this, or it didn't actually run it. We actually tried to run it, but it wasn't allowed to run. Another great functionality is really the network controls. So we know now that you deployed your containers on your environment, you want to be able to um, to make sure that they're communicating with what they're supposed to communicate with, or someone else communicating with it. So you want to be able to control all that. So we have a good network nanosegmentation controls. We're able to say that container A is allowed to talk to container B over port 80. It's not allowed to talk to it on any other port, or container C is allowed to talk to container A over port 443, but container A is not allowed to talk to container C. So we have those segmentation capability as well. In addition, we could also block access to some website or some external endpoints as well. So we could all do that. You could do it manually, or we could actually watch the network controls within the container as it's happening and build the policy around that really quickly. So these are some of the top risks that you want to be able to address. You want to prevent rogue containers from being deployed. You want to take care of supply chain attacks. You want to be able to limit the users, and limit the user and executable use. What's called attackers living off the land. You want to be able to prevent, compromised credentials. Make sure the network is properly configured, all the connections are correct where it's supposed to be, and you want to prevent any unknown zero-day attacks. The way you could do this through drift prevention and from the image profiling capabilities of Aqua. So really, this is where a good overall view that we have. So we have the build process here. So you want to be able to scan for vulnerability. You want to check for dynamic threat analysis after the scan is done. You want to be able to secure your infrastructure as well. Environment as well. We pretty much integrate with any orchestration providers and any cloud providers like AWS. You have the EKS environment, ECS environments as well. It doesn't matter. We work with all that. And then you also want to be able to integrate with your CI/CD pipelines and be able to scan early on. So all this is really handled from within Aqua. It integrates really well with your DevOps process. So, we just went over the presentation, but if you allow me, I want to go over some of the actual use cases that we went over and show you in live how that's happening.
I would love to see that. This is fantastic. Go ahead. This is great.
Great, awesome. So let's go ahead and change the screen. Do you guys see my environment, my UI now?
Yeah, absolutely. If you don't mind, I think if you could you maximize your screen a little bit, maybe it's kind of zoom in, and I think that'd be a little bit better.
Okay, great.
Awesome. That's perfect. Thank you.
Awesome. So this is like a quick overview of Aqua, right? So this is the dashboard that we have enabled. It just gives you good information about what's going on in your environment. This is the risk explorer that we went over earlier. So this is giving me a good 10,000 foot view of the actual risk. So this is live, right? This is really on my demo environment. You can see really quickly my namespace has SockSharp has a lot of issues here. I could zoom in here. I could click on one of the containers, and I can see the details of the risk over here on my left. All the details of the containers here. Any of the network calls that are being made. So we went over this in the presentation. So this is a good way to look at it. And then from here, if I go down to the infrastructure, I can see my infrastructure environment here. So here's one cluster. We actually did the KubeHunter test here. And the KubeHunter is the open source or Kubernetes penetration testing tool. So this actually it failed this particular check, the API version hunter. What this is saying is, the version of your Kubernetes environment could be obtained from that version endpoint. It might not be a big deal, but now the hacker has one extra piece of information that you shouldn't, to give them. So now they can start building a profile around your environment and craft the attack accordingly. So this, happens automatically on a daily basis, so you don't have to worry about it. Here are all the images. Yeah, question?
Yeah, no, I was just gonna say it's so funny that you made the comment about the slash shop because I use that in my demos all the time, and it's just hilarious that it has that many vulnerabilities. So I just wanted to make that comment. Real quick, so and just
Yeah.
making sure I'm clear. So this is Cube Hunter is actually running these tests against this infrastructure. So all right, is this, and you said it's a daily activity that is it configurable, or I'm just kind of curious.
Yeah, it's a daily activity that happens automatically. You could also do it on demand as well.
Nice.
Yep.
Okay. Okay, cool. Yeah,
Yeah,
I was
and
just curious.
here's a web page.
Okay. Yeah, I posted the GitHub link into the chat, but yeah, I've always wanted to use Cube Hunter. I just honestly never had time. But yeah, no, keep going. That was my only question.
It's really easy to use. Maybe I'll show you that here as well. But yeah, so the GitHub link is in the chat. This is the link to the actual page. You could just put in your email address, and it will. We could build out the test.
Awesome. Thank you.
Cool. Yeah. So here are all the images that I scanned in. So either through the CI/CD process or integrating with the registry. We could basically integrate with any registry that we have. Let's take a look at this Alpine image, for example. We can see like this Alpine 3.7 image. It has 2 critical, 3 high vulnerabilities, but it's marked as compliant because the checks that we've done here, or the list of all the checks we did, does not address any of those issues that we found here. The way this is really built is around the policy. So insurance policy, this is the policy that's been used to do the check. We'll look at, we have policy for the host, for the image, for the Kubernetes assurance policy, host, for functions, so your Azure, your Lambda functions or your Azure functions, VMware Tanzu as well. So let's take a look at the image policy, for example. So these are the controls I have enabled. So because none of these CVEs match the Alpine image that I scanned, that's why it was marked as as compliant. But you want to do is you want to be able to add some of the other controls. So let's go ahead and add vulnerability severity, and we're going to go ahead and add super user as well. So you can see there's quite a bit of controls we have, but I just quickly add these 2 controls. So image if it's configured to run as root or container administrator for Windows, and the next one is the vulnerability severity. What this is saying that if there's any vulnerability that's either lower above, medium above, higher above, or critical, I want to fail it. So typically we would use it as higher above. So if I have any vulnerability on my image that has a high severity level or above, it should fail it. So let's go ahead and save this one. Now if I go back to my images here, look at the Alpine here, you can see it's been marked as non-compliant. So I open up the Alpine image, you can see the policy is default, and the two things that we added, super user and vulnerability severity, has appeared here. So basically, for this to be a compliant image, I need to take care of all my high and above vulnerability, and I need to configure this image to run as not root user. When I look at the vulnerabilities, it shows me my 2 criticals and 3 highs, and it looks like 4 out of the 5 criticals have high and critical have a vendor fix. So all I need to do is really just update the package. So if I look at this one, for example, basically upgrade this package to this version or later, and it will be fine. The last one does not have a vendor fix associated with it. So in that case, I could just acknowledge that vulnerability. I just did this earlier. So I acknowledge that particular vulnerability, and it won't be a blocker to this image if you apply the other fixes here. Cool. So this is what the static scan is really about. It takes the image, it looks at it to see if there's any known vulnerability. The next thing I want to show you is our dynamic threat analysis, which is pretty cool. So let's go to DTA. Take this one, for example. Actually, you know what? Let me just remove this policy here. Let's just remove this one. And let me just remove this one. So let's go back here. So like this Xauto, for example, you know, this image would have been okay if you scanned it in before. We wouldn't find any issues. And then you would think that, oh, this image is fine. There's no issue, no problem here. But in this case, we, when you did dynamic thread analysis on it, we see that, oh, right, this is not something suspicious. We're able to capture all the activity here. We're able to see all the processes that are happening, like secure shell is being run, wget is being used to pull down something. And all these processes are being mapped to the minor attack framework. So we map it all to that framework and see what's going on. And as I scroll up, you can see the color is getting a little bit darker. You can see that there's a direct communication with an IP address instead of a DNS. Most people would use DNS just because IP address changes all the time. Then there's a communication with Showdown is being done. So why is Showdown being used here? Then Tor is being used, and you can see the colors getting a little bit darker. And then all the way at the end, we see a malware being deployed. A coin miner is being deployed. That wasn't there in the image when I first scanned it. It happened when the image was spun up. So you wouldn't have detected it otherwise. If you look at any other scanners, it would have came up as clean, and you would have known better. But because we did dynamic threat analysis early on, we're able to see that, hey, this image is not clean. It's not a good image. You don't want to use this. This is a bad image. And what's good about this one as well is, I detected the malware, but in most cases, if the malware is running in memory, for example, you wouldn't be able to detect it. You wouldn't be able to prevent it. But with this dynamic threat analysis, we're able to detect that as well. It doesn't matter if it's in memory or not. We're going to be able to see if there's a malware deployed. If it is, we'll let you know that, hey, there's a malware in this image. You should not use this image in production. So that's really our dynamic threat analysis part. The other cool feature that we showed you early on, excuse me, is our risk-based insights. So like in this example, I have 4,000 vulnerabilities. I'm not gonna. There's no way, and it's possible for me to go through all 4,000 vulnerabilities. Even if I sort it down to 3,000, 3,200 vulnerabilities, that's still a lot. My network attack vector is still a lot. But now that I look at those have the available exploit, that's 238. Those that have remote exploit available for is 121. And those that are actually exploitable, that are actually running on my environment at this moment in time, is 69. So like if I take a look at one of these, for example, here's the actual code, what it is. The remediation is to fix that, to update it to that version or later. Here's a link to the exploit DB. So this is the this is the actual code, the remote code execution for here Apache Solar. This is the actual code that can be used to penetrate that. Here's the steps to reproduce it, and they also, in this case, to give you a remediation here. So you have all this information. If this is out in the exploit DB, yeah, the hackers and the bad actors have access to this as well, and they're going to go ahead and to try to take advantage of it. So in my case, I have 69 of these vulnerabilities that I could take care of, that I should take care of. This is where I would concentrate as a security professional, these 69. I don't care about all the other ones. I just care about these 69 vulnerabilities. Cool. From here, we are to, let's go to my runtime policy. So here are the runtime policies. So we talked about scanning the image with dynamic threat analysis and the static scan. We look at the securing the through the benchmarks, through the runtime, through the host runtime policies. So now what we're looking at is like, once the image is allowed to run, what happens? We have a number of policies here, but I just created one for this particular demo called demo cluster. So a couple of things we're going to do is, we're going to check to see if the image is allowed to run. Block non-compliant image. If it's been scanned by Aqua, has it passed the check? Like the Alpine image, when I changed the policy, was marked as non-compliant. This will prevent that image from running. Block unregistered images. What this is going to do is going to prevent any image not known to Aqua. So if I had a hacker get into my environment and try to deploy a crypto miner, or maybe a ransomware or anything, it's not going to run. Aqua's going to block that. It's like, nope, I don't know what you are. You're not going to be able to run. And there's really no way around to running this. When I used to do this presentation in public, some guy would come up, really a guy much smarter than me, or girl, and they would come up and they say like, you know what? Let me add it. Let me see if I can break through it. And they would write their shell scripts. They would write everything and spend like 20, 30 minutes on my laptop and try to get around it, and they wouldn't be able to get around it. They're like, oh, yeah, I can't get around it. So it's very robust. What I want to show you really is this drift prevention. So right now I don't have it checked on. So in order for me to enable it, I just have to click on this checkbox and that's it. What this is going to do is going to prevent any executable that was in the original, that was not in the original image from running. This simple check is really powerful. I showed you what would happen. What happened if someone tries to download, tries to run a container that wasn't scanned or known to Aqua. This is what's going to prevent. This is what's going to protect our running container from that same type of attack. Say someone execs into a container or breaks into a container, and they're trying to deploy a crypto miner or a ransomware in there or something, a data exfiltration tool. This is going to prevent that. And all I have to do is to make sure that this is checked, and that's it. And the last one here on the bottom is the executables being blocked. So in this case, I'm going to block PS from running. And this is just one way to do it. There's more ways to do it properly. This is just an easy example. Let me go ahead and save this. It said restart required. It only said restart required because I had volumes being blocked. Volumes are usually are mounted when a container spins up. So therefore, you want to, if you make any changes to that, you want to be able to prevent that from, you need to restart your container. What I'm going to do now is I'm going to jump into my terminal and exec into a particular container. But let me just make it a little bit bigger so it might be easier for you to see on the screen. So let's take an example, kubectl get pr-n website. Okay, let's exec into this one of these containers, kubectl exec -it -n website, and we'll go into web server, and let's do the bash command. Let's clear it. Who am I? You can see I'm root, and you can see I'm root here anyway. So if I try to do ps, I get permission denied, even though I'm logged in as root, because I have ps as being a denied executable. But now let me show you what drift prevention is all about. So let me do a ping localhost. You can see ping is working fine. Which ping? It's in my bin directory. You can see I have ping here. So to simulate a drift, what I'm going to do is I'm going to copy ping to, let's just call it pong, to get ping pong going here. And there we go, we've got pong here. Pong is the exact same copy of ping. Now if I do pong localhost, I get permission denied. And that's really because pong is, is new. It's a new executable. It wasn't there before. So Aqua was like, hey, I don't know what you are. If you want Pong to run, you should take it back to the image and get Pong built in, and then I'll let you run it that way. Many times when I do this, people are like, well, what if you rename like a bad executable to ping, for example, or something that's allowed? I'll share an example of that. Would that work? And the answer is no, it won't work. You can see that data is working fine. Now, if I do ping local host again, you can see ping is working fine. I'm going to copy date to ping. And now when I tap in ping, I should get the date. It was allowed. Ping was allowed, date was allowed. So, to Aqua should be allowed, but no, Aqua is smart enough to know that you just can't rename a file. We don't look at the hash. It's really, our secret sauce. We go really deep into it to make sure that it is what it is, and it is supposed to be allowed to run. You can see that data is working fine. And just to show you that I'm not doing anything fishy, I'm going to disable drift prevention. Let's go ahead and save it. I'm not going to restart my container. And now if I do ping, I should get the date, and I do. If I do pong localhost, I'll get ping. There we go. And all I need to do to enable that is really this one little checkbox here, and that's it. Boom, done. Permission denied. And of course, all this information gets logged into your audit log. So you want, and as a security professional, you want to have the proof that, hey, this is what we're doing. We're able to see it. We're able to check against it. For your compliance need, you want to be able to provide the proof, and all that is, we have it on our logs. You could integrate your logs with the logs from Aqua to your AWS CloudWatch or anything else you might be using, so you have it all in a centralized location for compliance purposes. One thing I do want to show you last in here, I'll show you is, you want to be able to protect your containers from the network side of the house too. You want to be able to say that these containers are only allowed to talk to, maybe containers are inside or maybe within your organization, and you don't want it to connect, from anywhere else. So, we could do that as well. So let me just go ahead and let's remove the firewall policy. Oh, that's fine. Let's go ahead and click on services. What I'll do is I'm going to record actual traffic happening. Actually, I already did this before. Let's just. I could do it manually by adding the policy here, but I want to show you how we do it magic, watch the actual traffic. So this is good. I just click on record. What I'm doing right now, I'm looking for any network connection on any container in a namespace website. What's good about this is that, I don't care about IP addresses anymore. I don't care about the name of the containers. The old way to do it is to get the IP address or the name of the application, and you put it into your rule set, and it monitors that. The problem that is with containers is that containers spin up or spin down. The names change all the time. The IP address changes all the time. So if you try to do the old way to do it, there's no way you're going to keep up with it. So here, what I'm going to do is I'm going to do let's just do an apt update, for example, just to generate some traffic. You can see it's connected to dev.debian.org, and you'll see the traffic being drawn out over there. So these are all the traffic here. So now let's just clear it. I don't think I have curl on this package. Nope. So let's just do a quick apt install curl. Why? Oh, sorry. So we'll just quickly deploy curl and run it. The interesting thing here is, curl was not on the image before, so I'm downloading curl now and put it in here. So it should be blocked because if I remember, I enabled drift prevention. So if that's enabled, it should block curl, even though curl is a legitimate package and it's something that I need to use. So if I really needed to use it, I should go back to the developer, build it into the image, and rebuild the push out the image with the curl built in. And you can see I'm getting permission denied. So let me just quickly disable the drift prevention here. I'm just going to uncheck that checkbox, save it. I don't need to restart it. Let's go back to services, network map. Let me try and move this a little bit lower. So let's just do curl aquasec.com. It works. Let's just do curl google.com. It works. And you see google.com is here, aquasec here, and you can say, hey, why am I connecting to Google? I don't want to connect to Google. Google's evil. Let's not connect there. So let me just go ahead and save the rule. I could go ahead and say deny to Google. I can also do it manually. This is the outbound rule, but we also have inbound rule as well. It's the same thing. I could do a destination, could be anywhere, IP address, service, or domain. Servers is other containers in my environment. So this is how you would connect, net container to container traffic. But right now, I'm just really quickly, I'm just going to deny access to Google. I save the rule. I come back here, and let's do google.com. And you can see it's getting denied. It's not being able to connect. So you'll see really shortly here, you can see right there has been denied. You can see Google has like yellow or orange, red icon there. So we actually denied Google. We denied the container access to Google. So this is a great way to control what your containers are allowed to talk to. You know, and make sure that they only talk to what they're supposed to. If it's an internal one, you know, control over what port the container is allowed to talk to the other containers and whatnot. And again, you don't need to worry about the IP address of the container. You don't need to worry about anything else, like the name of the container, as long as it's mapped within the scoping rule that we set. In this case, the scoping rule is Kubernetes namespace website. We could actually do a lot more. You could do it by cluster, by daemon set, by label, pod name. We could also do it by a cloud attribute, host name, or image type. We got it pretty much covered there. So the idea really is this is how you're going to prevent hackers from getting in. If you use a tool like Aqua or any other tools, you want to be able to scan your image in first, make sure there's no vulnerabilities out there. And I showed you Aqua, but that's where I work, and this is what the tools I have available to me to show you the demo. But I hope this gave you a
Oops. Hey, Kashif, real quick. 1 second. I think I accidentally muted you. I was trying to unmute myself, and I accidentally muted you on accident. Let's see. Yeah, you might have to pop over to the site and unmute yourself. Apologies.
yeah,
It
okay,
was
cool.
such a strong finish too. Keep going. Try to do the strong finish. Go ahead. Don't let me
Yeah,
steal
no.
your.
No, that was it. So that's really what I was trying to say. You want to secure your build, you want to secure your infrastructure, and you want to secure it at one time as well. If that's how you really can secure your containers and prevent hackers from getting in or deploying bad malicious containers on your environment, really.
I just want to say, like, that was amazing. That was such a great presentation. I don't know. I'll speak for myself, right? This is definitely like a hobby for us, right? This is our little hangout, and I don't get to go and see a lot of cool, tools. I've always wanted to spend a little time with Aqua, but that was great. The drift protection, the way that you can actually switch binaries and it's still going to detect it. You making the comments about the crypto miners. I hear about that too. We
Yeah.
hate that. All of a sudden, hey, oh my gosh, my bill is fucking through the roof. We don't like that either, right? Like
Yeah.
we don't, it's security's day zero for us, right? So it's great that you're even talking about that because it's real life. So I just want to say thank you so much for coming, and that was a pleasure. Thank you so
Yep. Thank
much.
you for having me.
Yeah. All right,
Bye, guys.
everyone. Thank you so much for having us. We'll see you next time. I believe we have HashiCorp coming. So
Oh,
take care, and
thank you.
thanks again, everyone. Bye.
Bye.